evaluate selection. Oops. This time I get a solution that's extremely high over here. Okay. That's weird. And X and Y, that's maximum. More magnitude. Here?
Yeah, should be divided by anything.
So the unit of this wave speed is basically speed times length, right? Then it's times the value of the solution, and that's basically the same unit as the flux. The flux is the flux here computed is already multiplied by the length, and the unit of the flux is also wave speed times the solution, right? Because the wave speed is the derivative of the Jacobian with respect to the derivative of the flux with respect to the conserved values. So let me see if it's a boundary issue by kind of setting the boundary flux to be 0. So if I comment out this if statement, that means I am adding and subtracting to the same thing on the boundary. That means I'm ignoring what the boundary is doing. And let's see if that's diverges a lot earlier. So it's not a boundary issue. Okay, so maybe we'll continue to our finite. Yes?
For the absolute U term, should it be the magnitude if it's a vector? Right now you're just taking the absolute, right? You're not taking the magnitude.
Yeah, this is taking the absolute value of the normal component of the velocity. So I have this line is basically the dot product of the interface normal with the velocity, right? So if you write down the flux normal to the interface and take derivative of the normal component of the flux with respect to the state variable and compute its eigenvalues, this would come out. So the wave speed actually depends on just the normal component of the velocity, as opposed to the norm of the velocity vector. Yeah?
The concept was previously that the normal magnitude, will you just change time of magnitude to the magnitude normal?
14 and 15?
So NX is also magnitude normal.
Okay. Let's see. Nope. Okay, so this seems to be evolving in the wrong way, right? So the waves are going on the other side. So it still looks like a numerical dissipation not being sufficient. But I don't see. Just to change the sign to see if it's a sign problem. Maybe I messed up this. Oh no, maybe I messed up the sign somewhere. No, after changing the sign, this thing diverges much faster. So I think I have the correct sign. It's just somewhere the amount of numerical dissipation is not being added correctly somewhere.
Or if you just increase the
by like times 2. It's doing the same thing. Yeah. Okay, I guess I'll leave this to offline, and on the next lecture I'll tell you what's going on. All right. So so to prepare for next guest lecture, which is on Wednesday, please go and register on the link I think Mohammed sent. I think it'll help them coming in the future.